So, last class we have solved few examples by means of third angle projections and complicated object curved faces that I have finished. I have shown you how your curved faces coming into picture ellipse. Now, come to the another part of this orthographic views. You can adequately describe most objects with three orthographic views. As I said earlier, front view, top view and side view, it is sufficiently you can address about this object. If it is still complicated, then you may have additional 3 views, that means total 6 views are required. Now, view selection, as I said, view selections, if the object has an obvious top, then it must be the top view. If the object has an obvious top, it must be the top view. Minimize the number of hidden lines. Once you are choosing this is the direction of my view, then minimize the number of hidden lines in the front view, as I said. Use the most descriptive view as the front view. The view where you can see most of the features of the object, that you can describe your front view. Conserve space by choosing the depth to be the smallest dimension, because if depth is not smallest dimension, then it will be very difficult to plot in a simple A4 or A3 size of drawing sheets. Now, order of precedence of lines, maybe before 2 class I have discussed. So, if these are the things available, first this is the order, first is your farm object line will come, followed by your hidden object line, then followed by your center line, then followed by your projection line, then your construction line. Your drawing should look like, how your drawing should look like. If you look at here, this is your object is given, this is your front face and this is your A3 size drawing sheet. In your drawing sheet there is a size, here you have to write, explained in the first class, name, roll number, title and subject, and this is your top view, front view, this is your profile view, how it looks like. Just for example I am showing. Then these are for practice. You can try at your home. These are all different shapes has been given. You can try at your home. You can self practice so that your confidence level can be built up. Then next part is your, after this orthographic projection, next part is your dimensioning. Dimensioning techniques and conventions. An object has several features, many features. We need to specification for position, what is its position, size, length, width and depth. A dimension is not repeated, that is if a dimension is given in the front view, remember it is not shown again in another view. I will explain. If one dimension is given in the front view, it is obvious that same dimension will be other view will be the same, it should not be repeated. A feature is preferably dimensioned in the view where its shape is apparent, that is a circular feature will perfectly be dimensioned in the view where it appears circular. It is not like that if there is a circular view is there, if you are showing in other view it is a ellipse, then you cannot dimension the circular dimension in a ellipse dimensions. 4 aspects of dimensioning. This is a object, first is lines, second is symbol, third is figure, fourth is your nodes. Lines, symbols, figures and nodes. Now basic principle, show dimension in the view that shows the relevant features. That means if you look at here, I am showing the dimension from distance from here to here and what is the total distance, height from here to here and from here to center point what is this, what is the height and what is the radius or what is the diameter, what is the radius of this curved surface or the circle Again, what is the diameter of the drill? There is a drill or there is a hole, what is the diameter? Basic principle number 1, need not show dimension marked in one view in other. What do you understand? You see, here I have shown from here to here, this is the two view has been given. This is your front view, suppose for example this is your top view. Now here to here in the front view I have marked the dimensions, let us say this is D, and from here to here I have marked it, let us say this is E. Now same D and E cannot be shown again in the top view, this is wrong, because again and again you no need to show it, so that if somebody read this is a dimension, obviously in the top view this will be a D and E. Place dimensions outside the view. What is the number one position, number one point of basic principle? Need not show dimensions marked in one view in the other. First point. Second point, place dimensions outside the view as far as possible. You see, this is a sentence given as far as possible. If there is a sufficient space in that drawing sheet, then place the dimensions outside. There are two examples. Here the dimensions are outside. This is my figure, and these dimensions are outside. But here there are certain dimensions are inside. So this is wrong. So second point is place dimensions outside the view as far as possible. Third principle, take dimensions out from visible outline than from hidden lines. Take dimensions out from visible outlines than from hidden outlines. Look at here. These are all two views. These are two views. Here this is your hidden lines. Here this is your visible lines. Instead of doing dimensioning here, you take out here and dimension it. Avoid dimensioning from hidden lines, taking out from the hidden lines. Here this is your hidden line, this to this to this. Instead of doing this, you do this, this is your correct. Third point, this is your third point. Fourth point, give dimension from baseline, oblique, finish surface, oblique, center line of a hole. Give dimensions, remember, from the baseline. Number one is baseline. What is your baseline? Then finish surface. This part is your finish surface. Then center line of a hole. Center line of a hole. I am giving the dimension from the center. If there is a hole here, there is a hole here. Now this is a center point of the hole. This is a center point of this hole. From center to center the dimension has been marked. It should not be like that dimension has been marked from here to here bypassing the center. And here if you look at here, I have never marked from here to here dimensions. This is wrong. Give dimension from baseline, finish surface and center of a hole. This is a center of a hole. I am taking dimension from center of a hole to finish surface, center of hole to finish surface, center of hole to finish surface. Between the two center of the hole, so I am marking the dimension. Here it is wrong. Fifth point, give dimensions from baseline, finish surface, center line of a hole except when center line passes through center of a hole. This is a repetition of fourth point, but there is one exception, except when center line passes through center of a hole. That means center line passes through your center of a hole means, that means this center line passes through center of a hole, because there are three holes. In that case you can do it. The other part you can do it from here to here, between you can take it, not like from this hole to this hole, as a whole you can take it. Outcome, intention, what is the intention of the doing the dimension? Simple to draw, simple, clean, legible drawing, approximate number of dimensions, not too many so that you cannot read it, not too few, it should not be too less, it should not be too many, it will be easier for the manufacturer. Remember, the point will come why you are giving the dimensions, because once this views seen by the manufacturer, he can easily take the dimensions and he can easily read out what is the actual shape of this feature or actual shape of that object. Easy to read the drawing by machinist or builders. Type of dimensions. Two types of the dimensions, one is your size, second is your location. Type of dimension, two types, one is size. Look at the difference. Tell me what is the difference you are looking at here. One is size. What is the size of your dimensions you are putting? Other is your location, where you are putting the dimensions, locations. Component of dimensioning lines. If this is my dimension lines, arrow I put it, that means I am taking out, there is a simple dimension of this finished surface from this end to this end. This is the dimension line or this is the arrow. If I am taking this arrow, this is a dimension line, if you look at there, that means from this to this is your 3x and this to this is your x. This is your x, this is your 3x. That means once I draw it, then I will make it in such a way that this to this approximately it will be 3x and from this to this it is x. X is equal to 3 mm for usual drawing. This will come over the period of practice. It is not like exactly I will maintain that this will be 3 mm, 2.5 or maybe 3.2, this will come over the period of time, it will be the practice. 4 to 5 mm for larger drawing, 3 mm for your regular drawing. This is your extension line, this is your arrowhead. By freehand I have shown how I have drawn it. Suppose this is my dimensions, then how I have drawn it by means of freehand. See this side by means of freehand. That means here is approximately x and from here to here is approximately 3x. This is a leader line. Leader line means for a diameter of a drill, if this is a diameter either this side or this side, you take it out and do it like this. This is called, this dimension has been taken out and put it here, this is called leader line. Then from there you write it phi 200, here it is given phi is equal to 200. That means drill, unless otherwise, as I said in the beginning of the class, unless otherwise it is not mentioned, these all dimensions are in mm. So drill of diameter is equal to 200 mm. Dimension symbols, phi, this is for drill, 200 dimension, right, dimension figure. As I say size, here I said two types, size and locations. What is the size and what is the location? Here it is the size dimension figure. Where is the location? Here in terms of leader line. Leader line, again it is a straight line from here to here. Then angle greater than 30 degree, not equal to 0 degree or 90 degree or 30 degree or 45 degree or 60 degree preferred, greater than 30 degree. Drawn radial. In radial direction always it has to be drawn. You cannot do, as far as possible you cannot do like this, avoid this, try to avoid this. Depending upon the availability of space, look at here, depending upon the availability of the space. Now here in this case arrows I can do it because I have a available of space. Now here arrows I can put it, here arrows I can put it. But if you look at here, it is very difficult to put arrows inside. Here it is very difficult to put arrow inside because this is a very small dimensions. In this case you can take it like this, draw it from outside, you draw one arrow, then from outside you draw one another arrow so that it reflect. Then here you write it 40. But if you look at here, the arrow has been drawn inside the dimensions, here it is there. Here it is a half arrow, here it is a full arrow, because here in this case there is no space is available. If you look at here, here it has been marked, but here it is very difficult because this is equal, this is 50, this is 50, this is 50. So again it has been marked by arrow, here it is written 50 because it is very difficult to write inside 50. Two sides only preferable. If it is orthographic, any views, whether it is side view, top view or front view, if it is a front view, for example, only prefer two sides, this side or this side, this side or this side, this side, not all sides. If you start with the two sides, same thing will continue for other faces also. Arrow and text, placing of dimensioning. How do you place the dimensioning? Unidirectional and second one is your aligned. What do you mean by unidirectional? Second one is your aligned. If you look at here, unidirection, I am putting arrow writing E, D, B, C, this is the unidirections. But here E, D is aligned in these directions, B, C is aligned in these directions. So you can do it either unidirection or you can do it aligned also. Zones for allowed alignments, leader lines, arrows and text avoid, 30 degree to 45 degree it will avoid. Narrow space, if there is a narrow space, unidirectional. See, I am writing this way, this is very difficult to write, this is a narrow space. As I said earlier, arrow will be placed very difficult. Then in that case, how it has been done? Earlier, arrow is inside, so now it is not possible, then you put it outside arrow, write it inside. Similarly, in case of aligned case, same cases, it is aligned because in that direction the dimensioning has been done. Here it is very difficult inside, then you do it outside and mark it A. Two basic styles. There are two basic styles. One is your chain dimensions, second one is your parallel dimensions. If you look at your chain dimensions means it will be here, 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 it will be continuous in the same chain. Another one is parallel, like here it starts, then parallel to this, then parallel to this, then parallel to this. Both are correct. Both dimensionings are correct. This is the followed, either chain or parallel. But here once you have taken it parallel, you cannot do it arbitrarily dimensioning like this or like this, you cannot do it. This is wrong. Either you do it parallel or you do it chain dimensions. Combined style also possible. That means chain as well as parallel also possible. This is a chain as well as parallel. Most appropriately view, ensure clarity, precede with phi to distinguish from the length. If you look at here, length, phi has to be distinguished from your length. Here there is a drill, phi, here there is a phi, it should be very clearly distinguished. If I come to this example, arc of a circle, precede with r to distinguish from the length. This is your length from here to here, it means 260. This is your length from here to here, it is 250 mm. But the moment I do it like this, then this is your r. That means for this arc, this is your radius. Again this is arc, for this arc, this is your radius. How for narrow space the dimensioning has been done? There is a very narrow space. One arrow can be taken out and put it here 6. Then one arrow can be taken out, put it 22, here it can be do it. Even if small angles, 3 degree, 2 degree, 1 degree, how you are going to do the dimensioning? Take it, mark the arrow, here slowly you mark 3 degree, 0 minute, 45 second, because it is impossible to write it inside. Use of enlarged view to clarify your dimensions. Enlarged view, suppose this is a view, this is a view, then this is a small part of the dimension is not clearly specified. In a drawing, you can take an enlarged view of this, how it looks. Then show the dimensioning, so that The manufacturer can read what is the inside diameter, what is the inside diameter here, here to here what is the dimensions, what is the dimension here, what is the inside dimension here, what is the inside diameter also here, what is the spacing here, everything it can be marked. As far as possible you can enlarge for clarity. I will stop it here. Tomorrow I will start examples of dimensioning as well as I will proceed for your isometric projections. This is all about your orthographic projections and dimensioning. Thank you.